Okay, in this video I'll just do a couple more examples of areas under curves and that sort of thing. So for this one I'm going to look at this particular graph here. I'll just look it up. Y equals x cubed minus 2x. Okay, so what I want is this area under here plus this area under here. So I'm going to do that, x cubed minus 2x, and it crosses the x-axis. I've just done something so it's easy. Is negative square root of 2 and positive square root of 2. So I'll just do that. So back to my page, I'll just quickly sketch on here so you can see what I mean. So it looks something like this. And that goes up and up like that. It's terrible, but sorry about that. Let's find the total of this area plus this area here. And that's root 2 there, and that's negative root 2. And it crosses at the origin. And what was the function again? I've already forgotten. It was x cubed minus 2x. So function there, fx equals x cubed minus 2x. Okay, so what will this area be? The area will be this area plus this area. Now if you did this, if you went the area between negative root 2 and positive root 2 of f of x dx, what you'll get is that, well, maybe I should do it to show you, but if you type this on your calculator, because it's an even function here, you're going to get, if it's got the same area roughly here and here, they will actually cancel each other out and you get an area of 0, because this is a positive area and this is a negative area, and so they'll cancel each other out. So what you need to do is to not do this, you need to separate it into two pieces. So what it is, it's this area here, which will be negative root 2 to 0 of x cubed minus 2x dx, plus this other area. So if we add that area, but it's a negative area, so what we need to do is actually subtract it. Subtract from 0 to root 2 of x cubed minus 2x dx. Okay, add this area, we're adding a negative because that's a negative space in there. Okay, I'll do it, but I shouldn't really have to because it's quite a boring thing. X cubed goes to 1/4 x4, 2x goes to minus x squared, and we're evaluating that between 0 and negative root 2, minus all this, again 1/4 x4 minus x squared between 0 and root 2. In fact, I'm not going to do it. It's just boring. And so evaluate that, and you'll get your area units squared. So that's how you do it if you've got functions that go up and cross the x-axis and that sort of thing. Okay. One more example in this. I just want to show you y equals sine negative 1x. Okay. Find the area. Area under the curve, say between, where's the function defined? Let's say x equals 0 and x equals 1. We'll go all the way up to the end. Okay, x is 0 and x equals 1. So what does this function look like? Well, sine x, hopefully you know by now, hopefully you've done this enough time, sine x looks like this. Okay? And it goes between 1 and negative 1, and it goes between pi on 2 and negative pi on 2. Okay, so what this question is asking for is the area between x equals 0 and x equals 1. In other words, this area in here under the curve. So what you'd normally do, and let's give this a go. Well, that's easy. Area equals the integral between 0 and 1 of the function. The function is sine negative 1x dx. Sweet, no worries. Equals, well, we don't know how to, you don't know this yet, how to integrate sine or arc sine x here. And so we need to figure out another way. And remember, we can find the area of the inverse of this. If the inverse of sine negative 1x is sine x, we can integrate that. And so looking at this, it might be possible to do something else with it. In other words, if we find the area between the function and the y-axis, in other words this area here, then what we can do is subtract that area from this whole rectangle here, and that will give us the area in green. So it's just sort of a workaround when we don't know how to integrate. There's other possible ways to do it. So we can't do this. Let's try to find this other stuff. So let's do it between the y-axis. So currently we've got y equals sine negative 1x. Therefore, if we take the sine of both sides, we get sine y equals x, and that's our function of y. So in other words, the blue area will be equal to the integral between what? Well, it's between 0 and pi on 2. We're talking about the y values now, so we weren't concerned about the y values, between 0 and pi on 2. And our function of y, which is sine y dy. That'll be our blue area there. Not our answer, it's not what we're looking for. This is the area of the blue. Equals, let's integrate that. So we'll go sine y goes to cos y, doesn't it? Good, I heard you say negative. Fantastic, sine y goes to negative, and then pi over 2 to 0. I wonder if I can fit that properly or not. Equals negative cos pi on 2 minus negative cos of 0. That's what that area is. And so that's equal to negative cos pi on 2. Well, cos at pi on 2 is equal to 0, so that's just all equal to 0. And then plus cos of 0, which is just 1. And that's interesting, isn't it? This blue area there is just equal to 1 unit squared. So very, very interesting. There you go. There's the area there. That's not our answer. What we need to know is for the green area, it will be this rectangle here minus the blue area. So the area of the rectangle is equal to, how far is it up here? Well, that's pi on 2. Pi on 2 times by your width here, that's 1. So it's equal to pi on 2. So therefore, I'll go back to my green pen. The green area is equal to the rectangle, pi on 2, minus the area of the blue area, which is minus 1. And so there's your answer, units squared. And there you go. So if you're ever you're not able to perform an integration on a particular function, consider going to the y-axis instead. If you can integrate its inverse, then you're in luck, okay, which we're able to do then. So that's a good little trick to have up your tool bag as well. See you in the next video.